I don't know what just happened, but somehow this got interrupted and cut into two different pieces. Instead of writing the negative 5b, we are going to write the negative 8v plus 3v. We then group together, factor out the greatest common factor from both of those. For 2v squared minus 8v, it's going to be 2v is the greatest common factor. For 3v minus 12, it's 3. We then factor out the common binomial. And then we set both of those to 0 using the zero product theorem. And we get v equals 4, or v equals negative 3/2. Same process with number 20. We're going to add 3 to both sides. That gives us 7n squared minus 10n plus 3 equals 0. Identifier ABC. 7 is A, B is negative 10, C is 3. We then go A times C, or 7 times 3, which gives us 21. Then want to find the factors of 21 that add up to a negative 10. Because we're multiplying and getting a positive, but adding and getting a negative, that means that the number that both numbers are negative, because that's the only way that works. Negative 1 and negative 21, negative 3 and negative 7, and yep, that's it. In all fairness, 21 only has 2, so 2 sets of factors. So negative 3 and negative 7, so now we rewrite the original equation with our negative 3 and negative 7. Oops. Group them together. Now, when you group them together, make sure, I want to show you guys right here, this negative right here that I just accidentally erased, but I'll put it back. That negative right there, in front of the negative 7, so this one right here, we're going to change that to a plus a negative 7, and that just helps keep things a little bit clearer. So the greatest common factor of 7n squared and 3n is n, and we're left with 7n minus 3. The greatest common factor of negative 7n and 3 is negative 1. So I pull out a negative 1. That gives me a positive 7n and a negative 3. Basically switches the signs. It's like dividing by negative 1. And then that gives me the 7n minus 3 that I pull out. I'm left with n minus 1. Set them both equal to 0. And I get n equals 1, or n equals negative 3/7. 21, add 4, multiply them together, and we get negative 147. Now, factors of negative 147. 1 and negative 147. 3 and negative 49. We then go, does 4 work? No. Does 5 work? No. Does 6 work? No. Does 7 work? Yes. But we already have 3 and negative 149, so I don't know why I kept going. I'm just silly that way. So here we have 7m minus 49m plus 3m minus 21 equals 0. Greatest common factor of 7m squared and negative 49m is going to be 7m. And we're going to be left with m minus 7. Greatest common factor of 3m and negative 21 is going to be 3. And we're left with m minus 7. Factor out the m minus 7. We're left with 7m minus 3, or plus 3, equals 0. And we set those both equal to 0, and we get m equals 7, or m equals negative 3/7 is our solution. Okay. Same idea for number 22. That's how that would look. The factoring there is a bit difficult because we end up with 168. And we're looking for 168 factors of 168 that add up to 29. Because our C is positive and our B is negative, they're both negative. 1 and 168, 2 and 84, 3 and 56. If I add these up, I would get negative 169, negative 86, negative 59, negative 46, negative 34, negative 31, negative 29. That's what we're looking for. Now notice here, if I don't know how to do these like in my head, just grab a calculator. Go 168 divided by 1, divided by 2, divided by 3, divided by 4, divided by 5, divided by 6, divided by 7, divided by 8. There we go. Plug them in, factor out, and you end up with v equals 4/3 and 7/2. You should be able to look at the work and see how it's done. This is checking your work. You should be doing this by yourself. You shouldn't be using this instead of your own work. You should be using this to check your work. Okay, completing the square. That's what we do right there. See? Okay. So remember, you guys should have the steps for completing the square. It's hard. Don't do this without the steps in front of you. The first thing we want to do is get into ax squared plus bx equals c. So we're going to add 8 to both sides. We get x squared minus 2x equals 8. We then go b over 2a. It's not negative b over 2a, it's just b over 2a. I think I fixed that. Yeah. So we get 1. Whoa, okay. So I'm just going to go back. There we go. Okay. So we add 1 to both sides. That negative I take care of later. So we have x, because we go b over 2a is 1, b over 2a squared is 1, because 1 squared is 1. And then add 1 to both sides. This gives us a perfect square of x squared minus 2x plus 1. That is the factored out or foiled out form of x minus 1 squared. I just went and erased all my negatives. See how clever I am? Oh, the cleverness of me, to quote Peter Pan. So we have x minus 1 squared equals 9. We're then going to take the square root of both sides. That gives me x minus 1 equals plus or minus 3. Add 1 to both sides. I get x equals 1 plus or minus 3. Or x equals 4, that's 1 plus 3. Or negative 2, that's 1 minus 3. 24, same general idea. We add 80 to both sides. That gives me x squared minus 6x equals 80. b over 2a. So a equals 1, b equals negative 6. So b over 2a is going to be equal to negative 6 over 2 times 1, or negative 3. So b over 2a squared is negative 3 squared, or 9. And that means we're adding 9 to both sides. So now I have x squared minus 6x plus 9 equals 89. I'm going to factor out the left-hand side to x plus b over 2a, in this case negative 3 squared, equals 89. Square root both sides, x equal minus 3 equals the square root of 80, or plus or minus the square root of 89. Add 3 to both sides, and those are our 2 answers. 89 is not a perfect square, nor does it have any perfect squares as its factors, so we just leave it like that. (25) Add 45 to both sides, or subtract 45 from both sides. We get r squared minus 16r equals 34. A equals 1, b equals negative 16. b over 2a equals negative 16 over 2 times 1, or negative 8. b over 2a squared equals 64. And that's what we're going to add to both sides. That gives me r squared minus 16r plus 64 equals 25. Left side factors to r minus 8 squared equals 25. Square root both sides, r minus 8 equals plus or minus 5. Add 8 to both sides, r equals 8 plus or minus 5. So 8 plus 5, 13. 8 minus 5, 3. Those are our answers. 26. Subtract 50 from both sides. P squared minus 20p equals negative 40. A equals 1, B equals negative 2, 20. B over 2a is negative 20 over 2 times 1, which gives us negative 10. So B over 2a, B over 2a squared gives us negative 10 squared, or 100. P minus 10. So I then add 100 to both sides. Factor to p minus 10 squared equals 60. Square root both sides, so I have p minus 10 equals plus or minus the square root of 60. Add 10. So I have p equals 10 plus or minus the square root of 60. I'm kind of okay if you use that, but I want you guys to start understanding that that can be broken down. You can simplify that radical. 60 turns into 4 times 15. 4 is a perfect square, so we can pull that out and go 2 times the square root of 15, which gives me 10 plus or minus 2 radical 15 as the correct answer there. Subtract v squared, add 42 to both sides, and that gets us in the position we need to be in to complete the square. A equals 1, B equals negative 10, so B over 2A equals negative 5. B over 2A squared is 25. So we're going to add 25 to both sides. And we get v squared minus 10v plus 25 equals 67. That left side factors to v minus 5 squared equals 67. Square root both sides, v minus 5 equals plus or minus the square root of 67. Add 5, and we get v equals 5 plus or minus the square root of 67. 67 is not a perfect square, nor does it have any perfect squares as roots. Perfect squares as roots, we're looking at 4, 9, 16, 25, things like that. But we just leave it there. And those are our answers. Finally, we have 28. We're going to subtract 9a from both sides, add 40. So we end up with a squared plus 20 plus 16a equals 40. A equals 1, b equals 16. B over 2a equals 16 over 2 times 1, or 8. Positive 8 this time. Excuse me. B over 2a squared equals 8 squared, or 64. Add 64 to both sides, and we get a squared plus 16a plus 64 equals 104. Factor the left side to a plus b over a squared, or in this case, 2a, 8. So it's a plus b over 2a squared. Here, b over 2a, as we found out, equals 8. So we go a plus 8 squared equals 104. Square root both sides, so we get a plus 8 equals the square root of 104 plus or minus. Subtract 8, and we get a equals negative 8 plus or minus the square root of 104. 104, again, doesn't have is not a perfect square, but it does have a perfect square as a root. That's 4. So 4 times 26, that means the square root of 4 times the square root of 26, or 2 radical 26. So we have a equals negative 8 plus or minus 2 radical 26, and that's our answer. So 29 through 31, we're using the quadratic formula. So what we want to do here is put it into standard form. So we're going to add 7 to both sides. It's going to give me a 5 as a c. We're going to add 12x squared to both sides. And we get 6x squared plus 7x plus 5 equals 0. So a equals 6, b equals 7, and c equals 5. I forgot to put a plus in there. Let me do that. Okay. Erase this little thing and continue. So negative b plus or minus the square root of b squared minus 4ac over 2a. That's our quadratic equation or formula. So we're going to plug that in. Negative 7 plus or minus the square root of 7 squared minus 4 times 6 times 5 over 2 times 6. Now, in your steps, it says to go ahead and check the discriminant. Here we have 49 minus 120. That's the square root of negative 71. Now, we know we can't do the square root of negative 71, but we can do I, because over here, square root of negative 71 is the same thing as the square root of negative 1 times the square root of 71, or I times the square root of 71. So this turns into wait for it to catch up to me. I times the square root of 71, and then we just put everything else back in. Negative 7 plus or minus divided by 12. Now remember, we need to put this in complex number format because we have that I there. So this needs to turn into negative 7 over 12. That's our real number component. Plus or minus the square root of 71 over 12i. Because remember, we need it in that a plus bi format for it to be correct. So this is actually our right answer right here. Just so you know, all of these, all three of the quadratic formulas have I as an answer. This is how number 30 would look. I'm not sure what happened there. So we have negative 7 plus or minus I over 151. So we have negative 7 over 20 plus there. Technically the I should be on the other end, but you get the idea. So here on number 31, we're going to add 3p to both sides. That actually gets rid of my p's. So I have 7p squared plus 5 equals 0. And it makes sense. So if I were to quick graph that, because I know that my y-intercept would be at 5, it opens up. You can see why there are no zeros. What we're trying to solve for are zeros. Where does it hit the x-axis? Here it doesn't hit the x-axis, so our only answers are going to be imaginary. So a equals 7, b equals 0, c equals 5. That gives me negative 0 plus or minus 0 minus 4 times 7 times 5 over 2 times 7. So we have plus or minus the square root of 140 over 14. 140 breaks down to 4 times 1 times negative 140, 4 times 35. So the square root of 4 is 2. Square root of negative 1 is I. And the square root of 35 as well, the square root of 35. So we have plus or minus 2i radical 35 over 14, or plus or minus I 35 over 7. Again, the I should really look like this. I don't know why I was doing that. Plus or minus 35 over 7i, like that. Okay, so that's your actual right answer right there. So 32 through, we're using the discriminant to determine the number of real solutions. So I thought I drew little diagrams to say this is what it looks like. Okay, anyway, if it is, do I? Okay, I do. Okay. So if it looks like that, okay, so I have a graph that goes through in 2 places. That's what it looks like if any real number is my answer. So if the discriminant is equal to a real number, I have two answers. If the discriminant is equal to 0, I have 1. Getting annoying. And then if the discriminant is equal to a negative number, then I have 0 real answers, and that's what the graphs would look like. You guys can skip these. I'll explain it when I get back. So I've done the first, so basically, no, you guys can just pay attention and realize that there's a pattern here. So if it's a number that I get, a real number, the answer is 2 real solutions. If I get 0, there's 1 real solution. And if I get an imaginary answer, then it's no real solutions. So here I end up with 4 squared minus 4 times 3 times 3. That gives me 16 minus 36, or the square root of negative 20. That's an imaginary number, so I have 0 real solutions. 33, my discriminant, after I put it in standard form, is 4 squared minus 4 times 1, or 16 minus 16, or 0. Because the answer is 0, that means I have 1 real solution. 34, subtract 2 from both sides, so I have negative 8a squared plus 8a equals 0. My discriminant is 8 squared minus 4 times negative 8 times 0, so I have the square root of 64, or 8. That is a real solution, so I have 2 real solutions. A real number, so I have 2 real solutions. 35, my discriminant is 0, so I have 1 real solution. The discriminant is that part underneath the square root symbol in the quadratic. 36, put it in standard form. I get 5k squared plus 4k minus 8. Create my discriminant, square root of 4 squared minus 4 times negative 5 times negative 8. Gives me an imaginary answer, so I have 0 real solutions. And so on and so forth. So I want you guys to try the rest by yourselves. And if you guys still have problems after, hopefully, I doubt many of you guys are going to get this far in 2 days. If you do, work ahead on your own, and we'll work when I get back. Thank you, guys.